RNNs could process sequences but forgot too quickly. In 1997, researchers invented a brilliant solution, the Long Short-Term Memory Network, or LSTM. It gave neural networks a real memory system with doors that control what to remember and what to forget. The LSTM cell is like a conveyor belt with 3 gates. Think of it as a notebook with 3 special doors. The first is the forget gate. It looks at the current word and the previous memory, and decides what old information to erase. Reading the word he after a passage about Mary? The forget gate might erase Mary from the subject slot, because we've moved on. It's like an eraser for your notebook. The second is the input gate. It decides what new information to write down. After reading the word John, the input gate writes John into the subject slot. It's like a pen for your notebook. The third is the output gate. It decides what part of the memory to actually use right now. You might have stored lots of context, but only some of it is relevant for predicting the next word. The output gate selects what to reveal. Together, these 3 gates give the LSTM precise control over its memory. It can keep important information for hundreds of steps and forget irrelevant details. This solved the vanishing gradient problem because the memory flows through a protected highway that gradients can travel along without fading. In 2014, researchers created a simpler version called the GRU, or Gated Recurrent Unit. It combines the forget and input gates into a single update gate, and merges the cell state with the hidden state. Think of it as a streamlined LSTM. Fewer moving parts, nearly the same performance. Now let's talk about a powerful pattern, the encoder-decoder architecture. For tasks like translation, you need to read an entire sentence in one language and then produce the translation in another language. The encoder reads the input sentence word by word, building up a summary vector. The decoder takes that summary and generates the output sentence word by word. This was the dominant approach for machine translation for years. But there was still a bottleneck. That single summary vector had to capture the meaning of the entire input sentence. For long sentences, information gets lost. The solution to this bottleneck would change AI forever. That's the attention mechanism, coming in our next video.